welcome to Secondary to Chemistry with Mr. Kelechi. Now, in this video, I'm going to show you how to balance a complex redox equation in acidic medium. Why are we talking about redox equation now? We are speculating that the samples of our quantitative analysis for our forthcoming alternative B practical will be a redox equation involving oxalic acid and an oxidizing agent, KMNO4. And since we know that this equation or this reaction is a redox titration, so we are expecting that we might be asked to balance the redox equation in acidic medium, right? So how do we go across this? Balancing of redox equation is not as easy or is not like balancing our normal chemical equation. It has some few steps you have to take, and those steps is what I'm going to show you in this video. So stay tuned, and you might need a jotter because we might need one, right? So to jot down some important points. Now let's quickly dive into that. Our sample F, our sample D rather, which is for the acid, like I said, is oxalic acid and it is hydrated. Oxalic acid hydrated. And oxalic acid is also called ethane dioic acid. And this is the structure for that. Ethene 2 carbon dioic. So this is structure for ethane dioic acid, also called oxalic acid. Now, our reducing agent here is KMNO4. That's our oxidizing agent rather. Now, this acts as a reducing agent and this acts as an oxidizing agent for our redox titration. Now, let's simply balance a redox equation. Now, how do we write a redox equation? First of all, we have to take the active species only. In the oxalic acid, this water molecule is not an active species, so we are going to use it in our ionic balancing of our redox equation. So we simply take H2C2O4 combining with KMNO4, and in KMNO4, potassium is not an active species. So we'll be left with only MnO4 minus. Now, when these two react, since this is an oxidizing agent, manganese 4 oxide will be reduced. Since an oxidizing agent will be reduced to manganese 2, and oxalic acid will be oxidized to carbon 4 oxide. So this is how the equation will look like, but it is unbalanced. Now let's dive into that. How do we balance this? First of all, we have to divide this equation into two halves, the oxidation half and the reduction half. So the oxalic acid giving us CO2 and our Mn4 minus to our Mn2 plus. Now, between these two halves, which of them serves as the oxidizing agent, or which of them serves as the oxidation half, and which of them serves as the reduction half? Now, let's simply identify that. In oxalic acid, if you calculate the oxidation number of carbon here, we will be getting 3. While in carbon dioxide, we actually know it is 4. And we define oxidation as the increase of oxidation number. So from +3 to +4, the oxidation number is increasing. So we call this oxidation half. While if we calculate the oxidation number of manganese here, it is 7. And why here it is 2. You notice that it has been reduced. So reduction of oxidation number is called a reduction. That's the first step to do. Now, the second step, we will be asked to balance these atoms except hydrogen and oxygen. We have a special way of balancing hydrogen and oxygen. So how do we balance all other atoms? We notice that the carbon here is 2, place 2 electrons, 2 coefficients here in order to balance for the carbon. Why the manganese here is already balanced, so we'll leave it like that. Now, the second step, how do we balance for hydrogen and oxygen? It is very simple. We balance for oxygen by placing the appropriate water molecule on the opposite side. And we balance the hydrogen by placing the appropriate H plus on the opposite side. Let's take, for example, we have 4 oxygen here. It means that we have to add the appropriate water molecule, meaning we have to add 4 water molecule on this other side. We have 2 hydrogen here. we simply add 2H plus on the other side. That is how to balance for hydrogen and oxygen in a redox equation. Now let's put that into practice. Our oxalic acid, our carbon dioxide. Notice that we have two hydrogen here to add 2H plus here. MnO4 minus. Notice that we have 4 oxygen here. So what are we simply going to add here? 4 water molecule. Now, having added the 4 water molecule here, notice that we have introduced 8 hydrogen atoms. So what we simply do, we have to add 8 hydrogen H plus to the other side. We didn't balance for the oxygen because the oxygen is already balanced. 4 here and 4 here is already balanced, right? We only did that of the hydrogen because 2 here. We added 2 appropriate H plus. Oxygen 4 here. We added the 4 water molecule. And since we have introduced 8 hydrogen here, we have to balance for that 8 hydrogen on the other side. Now, the next step, we have to balance the charges. We notice that how do we balance charges? We balance charges by placing the appropriate electron on the opposite side, and electron is negative, so meaning that we are introducing a negative in order to cancel out excess charges so that those charges will be equal. Let's take for example, on this side there are no charges here, so the charge here is 0. On the other side, there's no charge here. 0 times 2 still gives us 0. But on this side, we have one charge here. 1 times 2 gives us plus 2. So on this side, we have 0 charge. On this side, we have 2 charge. And where am I going to add my electron? And how many electrons will I add so that these two charges will be equal? You notice that if I add 2 electrons on this side, it's like I'm simply saying plus minus 2. So this cancels this. We'll be left with 0 electron, 0 charge here, and 0 charge here. So by placing 2 electron on this side, I have balanced these particular charges, right? 0 charge here and 0 charge total on this side. Now let's simply do this particular the reduction side. The total charge I have here is minus 1 plus 1 times 8 gives me plus 8. And that simply gives me plus 7, right? Total. And on this side, I have plus 2 here. This is 0. 0 times it gives me 0. Total is plus 2. You notice that I have 7 charge here and I have 2 charge here. Where am I going to add my electron in order to balance the electron? If I add 5 electrons on this side, I have simply balanced the electron. Notice that if I add plus minus 5 here, I'll be left with plus 2 here and plus 2 here. So the charges here is now plus 2 and the charges here still remains plus 2. That's how to balance our charges. Now let's move forward. The next part is to cancel out the commons. Cancel out the commons.